of the review for Lab 3. I did forget to record it yesterday, so I apologize. Here you can see the lab manual. This should be about the same. Again, if you're using the PDF version, it might be slightly different, but as far as the page numbers, but the questions and everything are still the same. So these are the structures that you're supposed to know. I went over a little bit in the lecture about the difference between the apex and the base. Remember, the apex is the pointy part, the base is the flat part on the posterior superior surface. It's not the bottom. Oh, there's a cat. Yeah, I just kind of made, for me, a couple of notes. It's always good to remember the middle cardiac and coronary sinus, just where those are. The IV sulcus is the interventricular sulcus. There's the structures, you can label those, the conduction system. Okay, so the practice questions. I can't exactly remember if I had y'all do these parts, but just for your own records then. 6 structures that would be considered deep or internal. Valves, the septum, the fossa ovalis. If you put the foramen ovale, that's okay, just note that it's fetal. The coronary sinus in the right atria, not the vessel. And papillary muscles, tendinous cords. Those are all internal structures. Superficial structures, the atria, the ventricles, the vena cava, some of the great vessels, the superficial features, superficial vessels, the auricles that sit on the auricles. That is one thing that people generally have trouble finding. The auricles sit on top of the atria, and they're just these little kind of vestigial structures. We used to have a 6-chambered heart, and so the auricles are remnants of those chambers. On the superior half, you have your atria. Those are the big ones that you should definitely have. Pulmonary arteries and veins, coronary sinus, semilunar valves, great vessels, interatrial septa, the base, and the auricles. Remember, the base, again, is superior, not inferior. Inferior, you have your apex, your ventricles, bicuspid, tricuspid valves, and tendinous cords, papillary muscles. I'll let you do the circle star box thing if you want to. Okay, so function of the mitral valve is to prevent blood flowing from the left ventricle back into the left atrium. Okay, so for these questions, it's all about just knowing where the valves are going and what chambers and what portions of the heart the valves are dividing. Pulmonary semilunar valve is between the pulmonary trunk and the right ventricle. Tricuspid valve, that's on the right side of the heart. It's to prevent blood from flowing from, am I on the right page? Yeah. The right, sorry. I got mixed up with the notes. The function of the tricuspid valve is to prevent blood from flowing from the right ventricle back into the right atria. Aortic semilunar valve is to prevent blood from flowing from the left ventricle, from the aorta back into the left ventricle. So where does it come from? Where is it going to? Atrioventricular bundle is to carry an action potential from the AV node, to the Purkinje fibers. Atrioventricular bundle, AV node to the Purkinje fibers. Purkinje fibers is to carry an action potential from the bundle, AV bundle to the bundle branches. And the bundle branch is going to be carrying the signal from the Purkinje fibers to the intercalated discs. I'm sorry, the right bundle branch is going to be going carrying an action potential from the AV node to the right Purkinje fibers. Left bundle branch goes AV node to the left Purkinje fibers. The 2 vessels that are in the anterior interventricular sulcus, those are the anterior interventricular arteries and veins. Very straightforward. Posterior interventricular sulcus, you have your posterior interventricular arteries and veins. The vessels that lie in the coronary sinus, there are 3/4. You have your right and left coronary artery, you have your coronary sinus, and you have your circumflex artery. So in the coronary sulcus, right and left coronary artery, coronary sinus, and the circumflex artery. The 2 structures working together to prevent valve prolapse. Prolapse is when the valve goes from being down in the ventricle to popping up into the atria. That's going to be the tendinous cords and the papillary muscles. 17, the tendinous cords and the papillary muscles prevent prolapse. 2 fetal structures, your foramen ovale and your ductus venosus. You could also say your ductus arteriosus if you wanted to. These 2 structures respectively become your foramen ovale. The foramen ovale becomes the fossa ovalis, and the ductus venosus becomes the ligamentum arteriosum. Okay, completing the pathway of blood. If you start at the inferior vena cava, you're going to go into the right atria. Then you're going to pass through the tricuspid valve, and then you'll be in the right ventricle. And then you'll pass through this pulmonary semilunar valve into the pulmonary trunk. That's number 6. let me actually do this. I'm going to abbreviate. Inferior vena cava goes into the right atria. From the right atria, you go through your tricuspid valve. From your tricuspid valve, you go into the right ventricle. From the pulmonary semilunar valve, you go into the pulmonary trunk. From the pulmonary trunk, I'm sorry, that's not right. From the pulmonary trunk, you go through the pulmonary arteries. Pulmonary arteries take you to the lungs. From the lungs, you go to the pulmonary veins. From the pulmonary veins, you come into the left atria. From the left atria, you pass through the bicuspid valve. From the bicuspid valve, you go into the left ventricle. You pass through the semilunar valve, the aortic semilunar valve, I should say, and then you go out the aorta. So that is blood flow through the heart. All the structures that it passes through, you should know that. Okay, conduction system of the heart. So remember that there is a conduction system and there's a mechanical system. The conduction system sends the electrical signals. The mechanical system are the muscles actually contracting the heart. So another word for the pacemaker would be your SA node. I'm trying to type with one hand here. Doesn't work. Your SA node. From the SA node, the signal is then going to spread to the intercalated disc gap junctions of the atria. So remember, the intercalated discs and the gap junctions allow the heart to function in syncytium, so as if it was all just one cell. So the atria function together and the ventricles function together. So the signal starts in the SA node. This is my right side. The signal starts in the right atria at the SA node, and then it spreads. And as it's spreading, it's going down towards the AV node, but it's also spreading out across the atria, and it's going superior to inferior. So the atria contracts superior to inferior, pushing blood down, and then the blood, and that's it passing through the intercalated discs. From there, it's going to go into the AV node. Ooh. There we go. It's going to go into the AV node. Then it passes into the AV bundle. It's going to slow down at this point. So the SA node is has larger fibers and more gap junctions than the AV node and the AV bundle does. So the signal actually slows down, and that gives the atria time to fully contract. So as the signal is passing through the AV node and the AV bundle from the SA node, it's going to be allowing the atria to contract. From the AV bundle, you go into the right and left bundle branches, go into your Purkinje fibers, and then it's going to be in the right and left bundle branches of the ventricles, the intercalated discs of the ventricles, where it then spreads that signal around, and the ventricles will then contract inferior to superior, pushing blood up. An anatomical difference between the SA and the AV node has that smaller fiber diameter, like I mentioned, and fewer gap junctions. So those are the structural differences between the two. Anatomical differences, the structural differences, smaller fiber diameter, fewer gap junctions. The physiological difference between the SA and the AV node is the SA node has more leak channels, and it's going to spontaneously depolarize. SA node has more leak channels and will spontaneously depolarize. Okay, here is a nice little ECG, EKG, however you want to say it. I like giving these. I'm not going to give you a complicated one. I'm not going to give you someone that's in some kind of distress or ask you to read this cardiogram and give me some kind of and diagnose with it. But I do expect you to be able to look at a normal one, identify all the waves, the segments, both the electrical events and the mechanical events that are happening in each one of these. So you can go through and label this. You have your P, Q, R, S, and T. The P wave. So for this, I want you to put both the mechanical and electrical event that is happening. The P wave, you're going to have atrial depolarization and atrial contraction. Okay, so mechanical event, or electrical event, and mechanical event. The PR interval, this space from P to R, that's going to be your atrial plateau. I can never spell plateau, E-A-U. That's your atrial plateau. So that's this, again, that's the space where the atria are contracting. The depolarization initiates the contraction at the P wave. The QRS complex, that's your ventricular depolarization and contraction, as well as your atrial repolarization. So it's the atrial repolarization is hidden by this big spike of the ventricles depolarizing, but the atria repolarizing here as well. The QT interval is the ventricular cycle. So that is from Q here to T out here. That's going to be full ventricular depolarization, repolarization, contraction, plateau, relaxation. The T wave, this last one right down here, that is your ventricular repolarization / relaxation. And then your ST segment is your ventricular plateau. So again, it's from here, S to T, this segment, that's when the ventricles, the potassium and calcium channels are both open, so you have calcium coming in, potassium leaking out to kind of prolong that repolarization process until you get to that, until you get to the T wave, and it fully repolarizes and relaxes. So yeah, you should be able to know all of these segments, the electrical mechanical events, based off of the